Welcome to the PowerPoint presentation on Unit 4 of our subject Transmission Lines and RF Systems. The name of the unit is Waveguides. In this PowerPoint presentation, we are going to concentrate on three different kinds of waves, namely the TE waves, TM waves, and the TEM waves. So let us start by first seeing how the unit flows. At the beginning of the unit, we are going to consider parallel planes through which the waves are going to travel. That will be followed by the propagation of TE and TM waves in parallel planes. These two topics cover the first half of Unit 4. Followed by the two topics, we are going to see how the two waves TE and TM propagates through a rectangular waveguide as well as a circular waveguide. So let us start by seeing what a waveguide is. In Unit 1, 2 and 3, we saw the propagation of waves through transmission lines. We saw the characteristics of the voltage and current, and we derived various parameters of the waves when they propagate through a transmission line. But as the frequency becomes higher, the transmission lines are not much efficient. Hence, waveguides, which are close conducting structures, are used to transmit the electromagnetic waves. The waveguides are metallic tubes through which the electromagnetic waves travel from one point to another. So before directly going on to the analysis of waveguides, let us first see the rectangular coordinate system. The rectangular coordinate system contains three axes, namely the x, y, and z. And the electric and magnetic fields can extend over all the three axes. When mathematical analysis is made on the wave by using Maxwell's equation, it gives rise to a different number of field configurations, out of which we are going to concentrate on three, which are the TE waves, TM waves, and the TEM waves. The first kind of wave we are going to analyze is the transverse electric waves. As the name suggests, for example, let us consider the wave propagation in the z direction. When a wave is propagating in the z direction, in that particular direction the electric field is not present and is fully transverse or perpendicular to the direction of wave propagation. Such waves are called as transverse electric waves. The second type of waves are called as the transverse magnetic waves. Once again, let us consider the wave propagation in the z direction. Then, if the magnetic field is totally transverse to the direction of wave propagation, such waves are called as the transverse magnetic waves. The third type of waves are the TEM waves, expanded as the transverse electromagnetic waves. Again, when the wave propagates in the z direction, if both the electric field and magnetic field are perpendicular to the direction of wave propagation, such waves are called to be the transverse electromagnetic waves. So this diagram depicts the TE and the TM waves. Considering the direction of wave propagation, the first diagram shows the TE mode where the electric field lines are perpendicular to the direction of wave propagation. The second diagram, again considering the wave propagation, in the TM mode, the magnetic field lines are perpendicular to the direction of wave propagation. and hence termed as the transverse magnetic field. Thus, in this PPT, we saw the basics of transverse electric, transverse magnetic. Thus, in this PPT, we saw the basics of transverse electric, transverse magnetic, and transverse electromagnetic waves.